All right, hello. We are going to do our Algebra 1 lesson. I'm going to try to record these. You can use this code if you're watching this video and we're not in class. Feel free to use this code. You can go to student.desmos.com, type in GC7TVG, and you can join this and you can do this activity as well. And then you can be counted as present if you weren't if you weren't able to make class time. All right, so I'm going to go through this as a student and hopefully clear up some understandings. So what is 9 minus 2? Well, 9 minus 2 is 7, right? Just throwing that out there. So 7. And what does equivalent mean? I saw one today that was great. Now I lost it. But something that's equivalent is equal or has equivalent values, right? And I'm using the word equivalent, and that's not helpful. So anything that's showing that two things have the same value. So I'm going to say that, showing that two things have the same value. That is equivalence, all right? That one. Okay, so our next one, what we want to do here is just do the operations, right? So 16 minus 5. Let me see if I can make this any bigger. Oh, I can. 16 minus 5 is 11. This one, when we have a number over the other one, remember it's division, so 12 divided by 3 is 4. That dot shows multiplication. We don't really use the X anymore, the thing that looks like this. We don't say like 5 times 6 anymore because that X is now going to be a variable. It could mean a number, it could represent some sort of value. So we don't do this anymore. We would do 5 times 6, which is, let me get this in here, which is 30. And then 32 plus 16 will give you 48. All right, so those are the first answers there. Now we have some more. So -8 minus 12. I like to think of that as I owe somebody $8. I owe them 12 more. Now I owe them more money. So it's going to seem like my number's getting bigger. There's also a song that I can sing for you. We'll do that at a later date. So -8 minus 12. I actually add those and keep my sign. So it's going to be a -20. This, my negative sign, is just outside. So I'm just going to leave it. Right? There's only one there. A negative divided by a positive is a negative, or a positive divided by a negative is a negative. So either way, I hope I said it correctly. I don't even remember. Either way, this is going to be a negative answer. And 18 divided by 9 is 2. 3 times -7. Negative times a positive will be a negative 21. And then this one, we have 16 plus -20. These signs are different, right? We're adding two numbers that have different signs, so we subtract those values. 20 minus 16 is 4. Now we think about, well, which one is bigger, right? That's my song. It's not actually bigger. The positive number will always be greater than your negative number. But when I'm saying bigger, I mean which number, which integer, not integer, which digits are bigger. -20. If I owed someone $20, but I only had $16 because the positive is what I have, then I'd be short $4. So a way I can say short is I could say that's a -4. All right, and now we're going to do a little bit more. 12 minus 15. I can think, all right, this is the same as 12 plus -15. Let me write that. Let me bring this over. All right, so it would be 12 2 plus -15 is the same thing as 2 plus a -15. They're opposite signs, so I'm going to subtract them. So 2 minus 15, or 15 minus 2 is 13. 15 is bigger than 12, so it's going to be a -13. Our next one, -16 divided by -8. Negative divided by a negative is a +2. A negative times a negative, right? Maybe I should write that down real quick. If you are multiplying or dividing, If it is a positive number times a positive number, if we have two positive numbers, you knew this from 4th grade, that's going to give you a positive answer. Don't forget what you already know. If it is a negative times or divided by a negative, again, that's going to be positive. So same sign, you'll get a positive result. If it's a different sign, so positive times a negative or divided by, both same thing, it's going to give you a negative answer, and vice versa. A negative times or divided by a positive will give you a negative answer, right? So this is different from addition and subtraction, but let's see how we can do with those. So a negative times a negative is a positive. 4 times 4 is 16. And finally, we have a negative plus a positive, right? So different signs subtract. 28 minus 5 is 23. I'm going to use the sign of the bigger number. Which number is further from 0? That's really what it is. Which number is further from 0? Well, the 28 is further from 0. That's the positive one, so that's why it's a positive 23. All right. Now this stage, we are going to match, and these are a little too big now, so I'm going to make it a little smaller, and I'm sorry if you can't see it, but you can click on them to make them larger if you need to. All right, so I have 3 numbers here. I have a 5, I have a 4, and I have a negative 12. And now I'm just going to match them with each other. So for example, negative 5 times negative 1 is a positive 5. Negative 15 plus 3, different sign, subtract, keep the sign of the bigger number, then you'll be exact. 12 minus 8 is 4. Negative 16 plus 20, different signs, so again, I subtract. So that's going to be a positive 4. 24 divided by 6, positive 4. 24 divided by negative 2, different signs with multiplication and division, so it should be a negative answer. 16 plus a negative 11, different signs, so we subtract them. 15 divided by 3 is 5, and negative 4 times 3 is a negative 12. Now, what we want you to get from this, the point of this today, is not only, I mean, you probably knew that 24 divided by negative 2 is negative 12. You also knew that negative 4 times 3 is also negative 12. So, for equivalence, we can say that 24 divided by negative 2 is going to equal to negative 4 times 3. Now, they don't look like the same, right? This is beyond just answering the question, right? Which is what we had before, answer the question. Now, what we're doing is we're finding equivalent expressions. These two are equivalent. They both equal to negative 12. That's what we're trying to get from there, right? That they don't necessarily have to look related, but if they have the same value, then they're equivalent. All right. These Zoom tools sometimes. All right. Now we can make this expression harder by adding more operations to the expression. Here's an expression with both subtraction and division. Should we subtract first or divide first? And if you're thinking about, oh, what order do I do that in? The order of operations. And I read it this way for a particular reason that we will get to shortly. All right, so if I remember, if you don't remember and you did this before and you saw it, okay, we made a mistake and we move on. We do it right the next time. There's no parentheses, no exponents. So I'm going to do my multiplication and division. So I'll do this side first. 3 divided by 3. Oh, excuse me. I'm getting ahead of myself. Should we subtract or divide first? We should divide first. All right. I'm just going to hold that. Leave that for right now. If we subtract first, what do we get? All right, let's follow directions because that's always a good thing to do. So if we subtract first, we would do 30 minus 3, which is 27. Then we do 27 divided by 3. We're just moving left to right if I was just reading it. 27 divided by 3 is 9. Good. All right. If you divide first, what do you get? Let's change my color here. We'll do green. And we'll say, okay, now I'm going to do Actually, well, I'll leave it like this. I would normally circle that in there for a reason, but even so, yeah, let's do it the right way. Circle that in there. -3 divided by 3 is -1. Then I bring down this 30. This 30 just came for the ride because I already took care of this. And maybe you should have rewritten it. So if that's confusing, let me know. 30 minus 1 equals 29. Are the answers the same? No, they're not the same because we did them in different orders, right? And the first time I made my number smaller before dividing, right? My 30 went to 27 and then I divided by 3. The other time I divided first, so I made that number smaller and then I took less away. All right, we will be playing with this, and I know that that language is mixed math, but that's okay. If we use the correct order of operations, which answer above is correct? I meant the previous question. So which answer is correct? It would be this 29. All right, if I add parentheses, no, let's clean this up. If I add parentheses, now which answer is correct? Well, parentheses comes before division. So we would actually do the subtraction first to get this 27, to get the 27, and then we would divide. So which answer is correct? It would be that 9 this time. And explain why the order of operations is important. Well, if we want to get to the right answer, right, we need to use the order of operations. It is the agreed upon reason. Also, which I'm going to get to that in this next one, I believe. We're on 10. Let's jump to 11 because I want to go through it all together, right? Clear off. There we go. Okay. I wrote it vertically. They have it horizontally. Doesn't matter. The question is, why are M and D the same color? Like in this case, they're both red. And in the A and the S, the addition and subtraction are blue. Why? Well, they're done at the same time, right? As soon as we have just multiplication and division together, so let's say 10 divided by 5 times 2, as soon as we have that, we go from left to right. We say, we say 10 divided by 5 is 2, 2 times 2 is 4, right? If we did it incorrectly, we would have said 10 divided by 5 times 2. We would have done 5 times 2 first because M technically comes before that. But no, it's just for the mnemonic. 5 times 2 is 10, so we would do 10 divided by 10 and get 1. And that's not the correct answer, right? Why is this true? Well, multiplication and division are inverse operations. So what that means is they undo each other, but they're together, right? Dividing by 5, excuse my dog, dividing by 5 is the same thing as, I could say 10 times 1/5. Because if you remember your division of fractions, you keep flip, some of you, if you remember, right? You would keep your first term, you change, so 10, you change this to multiplication, but you don't use x's because we don't do that anymore, and you flip this last one from 5 over 1 to 1 over 5. All right, so you could change it to multiplication and then times 2, and again, I could go in any order I wanted to. I could do 10 times 2 is 20. 20 divided by 5 is 4. Right there. I could do 10 times 1/5. Well, 1/5 of 10 is 2. 2 times 2 is 4, etc., etc. Okay, so the reason that M and D are together is because they end up doing the same thing. And if we, as we elevate our math levels, we're not going to do all the division anymore. We might multiply by fractions. So that way I can play with numbers and manipulate them the way I want to. Same thing with addition and subtraction. So if I have 5 minus 3 plus 2, right, I could say, oh, well, A comes first. So I do 5 minus 5 is 0. But that's not right. If I have $5, I spent 3, so that means I have 2 left. Then I earned 2 more dollars. I have in total $4, right? Why does that work? Same thing. Addition, subtraction are inverse. So this is really 5 minus 3 plus 2. I could say this is 5 plus negative 3 plus 2, right? Why is that the advantage? Why do we want to do that as opposed to subtracting? Well, now I can add in any order I want. If I want to, I could do 5 plus 2 is 7. 7 plus negative 3 is 4. Do it in any order you want. Negative 3 plus 2, negative 1. Negative 1 plus 5, 4. The advantage of changing it to plus a negative, there's so many. And you get to do it in whatever order you want. That helps with like, if you're doing some mental math, we'll talk a lot about mental math of like, all right, I'm going to find my 10 pairs and it makes me do my math faster and easier. Always about the faster and easier. All right, so there are a few more examples. I'd like you to try those out here. Something like this one, feel free to like draw a line across and do your order of operations. So 21 minus 5, that's parentheses, that's going to come first. That is 16 divided by 8. Now I can do my 16 divided by 8, which is 2. Otherwise, I would have done 5 divided by 8, got 5/8, some crazy number. Crazy numbers still need love too, though. I don't hate on crazy numbers. Okay, then here we would go and do our multiplication first. So 20 minus 8 equals 12. All right, so there are a few more examples to go through on this one. I want to see what you can do. Remember, please, if you would like for me to see that you're doing your work, use this code. Let me clear off all my drawings. Use this code, try it out, see how you're doing, ask us questions. We're here for you, but the order of operations, it's not going anywhere. You have to do that for the rest of your math career. So I'd suggest giving it a shot. Come to me with questions, and we'll see you soon. All right, thank you.